Assalamualaikum and hello to all. Today we are going to proceed to chapter 6, Periodicity. At the end of the lesson, you should be able to describe the variation of atomic radii, whether it increase in size or decrease in size. Compare the atomic radius of an element and its ion. Ion means whether it is cation or anion. Okay, this one on next class, electronegativity, and this one on next class. Okay, size of atom and ion. Okay, it actually depends on two factors on the periodic table. Why the atom, the size of the atom or the ion is like that. Okay, so it depends on two things, two major factors. So the first one is shielding effect, and the other one is ZEF or effective nuclear charge. So what is shielding effect? Okay, shielding effect refers to the inner electron. Okay, inside here there is electron, right? The inner electron, inner electron. Okay, that move around. So let's say this is the electron that we are going to study, the electron of interest, the one that we are going to study. So what will happen to the attractive forces of this electron to the nucleus? This is nucleus. Nucleus, there is proton. So proton here will attract the electron. But what will happen if you have inner electron? Okay, this is inner electron. Inner electron move around, right? It move around, it move around, it move around. So this electron cancel some of the nuclear charge. The electron in between nucleus and the electron that we are going to study cancel some of the nuclear charge. What is nuclear charge? Nuclear charge is the attractive forces that proton can make to a certain electron. So what happens is we expect the electron to be at this side, at this position, but because of the inner electron that shield the nuclear charge, maybe, just maybe, the electron is not at this position. It is maybe here. Okay, the electron may be at this side. Why? Because it experiences a lower attractive forces. Why does it have lower attractive forces? Because the inner electron cancels some of the nuclear charge. Okay, that is about shielding effect. So it means that the higher number of inner electron that you have, the higher the shielding effect, and this is true. So for example, if you can see here helium, okay, helium here only have one orbit, so there is no shielding effect. But when we go to neon, okay, neon here, there is one shielding effect. There is one orbit, inner orbit. Okay, aluminium there are two, not aluminium, Ar, sorry, Ar, okay, there are two. And for K krypton there are three inner electrons. So we expect the size of this atom will become larger due to shielding effect. If I write down in short form, it means that size will increase when shielding effect increase. Okay, this is the short form lah. So size increase when shielding effect increase. How do we know shielding effect increase? Because there is higher inner shell. Okay, higher inner shell. This is the short form that you can use to easier to study this topic. Okay, the effect, shielding effect is the effect when the inner electron shield the nucleus attraction towards outermost electron. Okay, this is the outermost electron, outermost electron, outermost electron. Okay, as we move down the group, if you have periodic table, down a group means that we are looking down a group. If we move down the group, the number of shell increase. This is correct because period refers to the number of shell, right? 1, 2, 3. Okay, down the group, it means the shell increase. So more inner electron. And of course, shielding effect become larger. Okay, shielding effect become larger. And when shielding effect become larger, what happens to the electron? The valence electron will experience lower attractive forces, so it will move further away from nucleus because the attractive between the nucleus and valence electron are weaker. So the size or the atomic radius will increase. Okay, next one is ZEF, or effective nuclear charge. Okay, Z refers to nuclear charge. EFF here refers to effective. So effective nuclear charge. What is effective nuclear charge? And there is a formula actually for you to calculate Z minus S. What is that? Z is the number of proton. The number of proton. And S refers to the number of inner electron. Okay, inner electron only, not including the outer electron. We don't include this one. We don't calculate this outer electron. So the inner electron only. Inner electron. Okay, so what is ZEF? Okay, in simple word, ZEF means how strong the nucleus can attract the outer electron. Okay, that is in simple words. Okay, how effective or how strong the nucleus or the proton can attract the electron at the outermost shell. Okay, so let's look at this example. Phosphorus. Phosphorus is P. Okay, so following the formula, effective nuclear charge is equal to Z minus S. Z minus S. So Z is the number of protons. So number of proton is 15. Okay, correct. So this is the number of proton or the nuclear charge. Nuclear charge is the number of proton. Number of proton. Okay, kenapa jadi macam? Okay, number of proton equal to number of charge. So inner electron. So inner electron in this orbit one there are 2. So that's why it is written 2 here. And at the second orbit there are 6. 8. There are 8 electrons. Okay. So based on this formula, Z minus S, it is actually positive 5. So that is the numerical value for Z. Okay. So what happened? What is the effect the Z can give to the size of the atom? Okay, the higher the number of proton with the same number of shell, this one usually at if we go through a periodic table, means that we go across like this. So across a period, because across the period the shell is the same, right? The number of the period here refers to the number of the shell, right? So if we look at period 2, it means all of the elements here or the atoms here is having 2 shell, okay, or 2 orbit. But the proton number increase, right? The proton number increase across the period. Okay, proton number increase. Okay, proton number increase. So if you have a greater number of proton of an element with the same number of shell, the greater the effective nuclear charge. Okay, the more positive felt by the valence electron. Okay, the valence electron. Okay, remember this is nucleus. Okay, let's say this is nucleus. This is inner electron. This is outermost electron. So it means that this outermost electron will experience a stronger nuclear charge, a stronger nucleus attraction. Okay, stronger nucleus attraction towards valence electron. The smaller size of the element because of this because of this electron have stronger nucleus attraction. So what happens is this electron may be move closer to the nucleus. Okay, maybe this is the actual position of the electron after it is being attracted strongly by the nucleus due to the higher Z. And because of this, the size of the element decrease, or the smaller size of the element. Okay, so next, how shielding effect and Z affect the size of the atom? Okay, so shielding effect, if you go down the group, the major factor that can affect the size is shielding effect. Okay, down the group. This is down the group. Okay, down the group. Let's say we take this group, group 2. Okay, group 2. Okay, we take group 2. So down the group. Okay, down a group. Okay, down a group. Okay, let's say group 2. So what happened? The number of shell increase. Okay, number of shell or the orbit increase. Okay, number of orbit increase. Okay, what happened when number of orbit increase? It means that shielding effect increase. Shielding effect increase. Okay. Shielding effect increase. After shielding effect increase, what happens to the attractive forces from the nucleus to the outermost electron? Outermost electron. Okay, so attractive forces from nucleus, sorry, wrong spelling, nucleus to valence electron will become lower, right? Okay, lower because shielding effect is higher. So what happened to the size? So atomic size become larger. Okay, so that is what happened in terms of shielding effect and the size of atom. Okay, next we go across a period. Okay, let's say we take a period 3 here, period 3 here. Okay, we take period 3 here. Okay, period 3. Okay, so across a period. Okay, so across a period, what happened? Okay, so across a period, sorry, it's not easy to write big digital pen. Uh, sorry. Okay, across a period. Okay, across period, what happened? Number of shell, does it increase? No. Number of shell is the same. Because if you look at period 3, it means it only have 3 shell. Number of shell is the same. Okay, but what have changed? You should remember that periodic table is arranged by increasing order of proton number. So from left to right, the number of proton increase. So what we can say is that proton number increase or number of proton increase. Okay, number of proton increase. So what happened when proton number increase? You should expect that when proton number increase within the same number of shell, ZEF will increase. What is ZEF? ZEF is effective nuclear charge. What is effective nuclear charge? Effective nuclear charge is how strong the nucleus can attract the outermost shell. So ZEF increase. So after ZEF increase, what happened? So it means the attractive forces of nucleus, sorry, always wrong spelling for this one. Nucleus, okay, there is pasal nucleus towards to valence. Sorry, aduh, sorry. To valence electron increase, right? ZEF increase means electronegative forces of nucleus to valence electron will also increase. Therefore, what happened to the size? Size of atom becomes smaller. Okay, so that is how shielding effect and ZEF affect the size of the atom and how it can relate to the periodic table. Okay, next we are looking at the ions, okay, cations and anions, and compared to the neutral atom size. Okay, let's see for this one. Okay, from here, Na is sodium. Sodium neutral. This one is neutral. The size is 154 picometer, whereby the sodium plus Na plus is 116. So this one is smaller. So Na is smaller. Na plus is smaller than Na. Okay, the same thing that happened to magnesium. Magnesium neutral atom is larger than Mg2 plus, or Mg2 plus is smaller than Mg. Okay, this is cation. This is cation. So cation is smaller than its neutral atom. Okay, fluorine neutral, when it is negatively charged, the negative charge is larger. The same thing for chlorine. Chlorine negative charge is larger. So what we can say here? Okay, so positive ion is always smaller. Okay, positive ion is always smaller than the neutral atomic radius of the element. Okay, and for the negative ion or anion here is always larger. Okay, so you need to remember this one. But why Na plus is smaller than Na? Why fluorine minus is always larger than fluorine? So let's see the reasons here. Okay, cations, positive ion. Okay, so if I have Na and Na plus, which one is larger? Na, right? Na. So Na plus is smaller. So positive ion is always smaller than corresponding neutral atom. Why? Positive ion lose valence electron. The number of proton remain the same. Okay, it have less number of electron, but number of proton remains the same. So what happen is the remaining electron that still in the atom will experience greater attraction towards the nucleus. For example, sodium is 11, proton number is 11. Even for sodium plus, yeah, the proton number is still 11, but electron for Na plus is 10. Okay, this one is 10, but this one is 11. So it just imagine 11 proton pulling 10 electron. Which one is easier? So of course easier to attract 10 electron compared to 11 electron. So that's why the electron experience greater attraction toward the nucleus. So it will be smaller than its neutral atom. And this thing actually happened because of higher ZEF. Yeah, in this case, when I say higher ZEF, it means that the higher attractive forces experienced by the outermost shell. Okay, if you calculate using the Z minus S, it's still the same. The number will be always the same. But what I want to say here, the attractive forces of the nucleus towards the outermost shell is much stronger. Okay. Okay, anion, negative ion. So negative ion, earlier we have studied about fluorine compared to fluorine minus. So which one is larger? So the negative ion is larger. Why is it larger? Because it have more electron. Is it about shielding effect? Okay, no, this is not about shielding effect. This is about electron repulsion. Okay, electron repulsion. You need to remember this one. Electron repulsion. Okay, electron repulsion. Okay, it means that the electron inside the atom will repel each other. So because of the repulsion that occur, the electron will spread out and experience lower attractive forces towards the nucleus, or less attractive forces towards the nucleus. Therefore, the outer shell expands, and that is the reason why negative ion always larger than its neutral atom. Okay, so that is all. So good luck in understanding this topic, and we'll see again on more explanation about periodicity. Bye.